Okay, so in the last video, we talked about average velocity over a time interval. So if p is the position at time t, and we said the average velocity from time A to time B is given by the change in position divided by the change in time. So the position at B minus the position at time A divided by the length of the interval, which is B minus A. And so this is a formula. If I give you any interval of time, I can compute the average velocity at that time. Now, what if I wanted to say, what is my velocity at a certain time? So say I'm driving in my car and I want to know what was my velocity or my speed at 230, right? So this formula gives me a way to say, like, between 230 and 240, I understand how fast I was going. And that can be an approximation. Like if you say, if somebody asks you, how fast were you driving at 230? Well, you can say, well, between 230 and 240, I averaged 50 miles an hour. And they say, well, yeah, but how fast were you driving right at 230, right? 10 minutes is a long time. It could be anything, really. And you say, that's true. So let's try to make my estimate more precise. So I'll say from 230 to 231, my average velocity was this amount. And they might say, well, yeah, but still a minute is pretty long. So how fast were you driving right at 230? And you might say, okay, well, in the 10 seconds after 230, I was driving this fast on average, or in the 1 second after 230, I was driving this fast on average, or in the 1/1000th of a second after 230, I was driving on average this fast. And at that point, they might say, okay, yeah, that's probably a pretty good estimate of how fast you were driving right at 230. If you can tell me the average velocity for 1/1000th of a second, that's probably pretty close. And so what are we doing here? This is a very familiar process from before. Like what we're doing is we're sort of taking a limit as the interval length is going to 0, or as the time A is going to time B. They're both approaching t. Like, what is an instantaneous velocity? Really what I want is sort of an average velocity, but only at one point. So only from time t to time t. That's how you can think of it. Like I want the average velocity, but the time interval has length 0. It's instantaneous. Unfortunately, if I plug in A and B both equal to t, I can't use this formula anymore, right? So if A and B are the same, then this formula is undefined, right? I'm dividing by 0, so it's undefined. So instead of using this formula, what we'll do is we'll take a limit formally, and we define the instantaneous velocity as, let's say at time t. So this is going to be the limit as b goes to t of p of b minus p of t over b minus t. So here you can think of A as my, the starting point is time t, and the ending point is close to t. That's what I'm saying. So the ending point is getting arbitrarily close to t. Another way to write this is the limit as, let's say, h goes to 0 of p of t plus h minus p of t divided by h. So notice h is t plus h minus t. So what I'm saying is I'm taking my position at time t plus a little bit, something tending to 0. I'm subtracting my beginning position, and I'm dividing by this little bit, the length of the interval of time. So this without the limit, this would tell me my average velocity over the time interval from t to t plus h. So over the time interval of length h. And now if I let that interval go to 0, I can take the limit. And if this limit exists, this is a reasonable way to say this was my velocity at time t. And this is actually how we define it. So we define the instantaneous velocity as this limit.